All right, so today's lesson is going to be the first of Unit 13, 13.1, which is absolute value inequalities. So there's really two cases that you're going to encounter with these types of problems. The absolute value of something, okay, it's not always going to be just x, is going to be less than a value, or it's going to be greater than a value. So these are the two things that can occur. This is an and an or. And means there is a value that's sandwiched between two other values. And or is when it can either be less than something or greater than something. So the visual here helps you have an understanding of what that looks like. So these are all the values between those two values here. And here it's excluding these values in the middle, but there's values to the left and to the right of each of those values that satisfy the inequality. And this is how we would write it in set notation, the total amount of values that would satisfy the inequality. So go ahead and read through the steps, isolate the absolute value expression, and make sure it is on the left side. Determine if you have a less than case or a greater than case, solve, and then write your solutions as an interval. Now, with this step here, if you don't determine it right away, I'm going to show you a way you can determine it throughout the problem as well, by just kind of having an understanding of what you're looking at. So here you can see that our absolute value is by itself, which is what we want, and we look at the inequality here. So as we can see, the inequality is case 1. It's less than, so it's going to be an and inequality, okay? So let's go ahead and solve it. We're going to have to solve it two separate ways, okay? Because an absolute value equation represents the positive and the negative side. So here's what you're going to do. I know it's been a while since you've solved these, but you have the regular case, and then you have the case where you make the left side negative. Now, it does matter which side you make negative, because if you make the wrong side negative, what's going to happen is when we divide by a negative over an equality, it flips the inequality sign. So we do have to be careful of that, where we make sure we make the left side negative so that we don't mix up the inequality. So over here, I'm going to solve. So x is less than 3. And then over here, now you can either choose to distribute that negative or you can divide by it, either way. I'm going to add the 1. And when I divide by it in negative, it's going to flip my inequality. When I divide by that negative 2. So x is less than 3, but greater than negative 4. So as you can see, it's an and because of the situation as well, and because we determined it was less than, so it was going to be an and. So we can write it like this. We know that x is somewhere between negative 4 and 3, and notice the type of inequality symbol we have here. There's no line underneath either of these, so to write it as a set notation, it's going to look like this. This is our solution set. Now, to graph this on the number line, you're going to plot both these values and a few around it. I don't have enough room, but it should be fine. And then both of these have inequality symbols that don't have a line underneath them. So we're going to put circles or open circles or curves. You can do it either way. So we have a curve here and here. And we're talking about all the values between these two. Now you could have also used an open circle as well instead of the curve bracket. All right. Next one. So as you can see for this one, it's greater than, the absolute value is isolated, so it's going to be an OR. But you're also going to be able to determine that based on the information you get at the end of the problem. So you're going to solve it two ways. The positive and the negative version. And then I'm going to do it a different way this time. Remember, there's a -1 here, so I'm going to start by dividing by that. When I divide by a negative over an inequality, I have to flip the inequality sign, which I did. I'm then going to add 6 to both sides and divide by the 4. Now, notice here I didn't flip the inequality because I divided by a positive 4. It doesn't matter if the number you're dividing into is negative. So x is either greater than 4 or less than -1. As you can see, that excludes all the values between those two values. So this is an OR. So to write this in set notation, it can either be less than -1. So that's all the values from -infinity until we get to -1. Or they can be values from 4 to positive infinity, because values that are greater than 4. So it's excluding all the values between -1 and 4. So on my number line, so it's values that are greater than 4 and less than -1. And as you can see, it's excluding all these values here. Okay, now this one, as you can see, the absolute value is not isolated. So before we do anything, we're going to isolate the absolute value by getting it by itself. So moving everything else over. Like that. Now we can see that it is a greater than, so we know it's going to be OR because this is a greater than symbol. Now we're going to solve it two ways. We have the regular way, and we have the negative version. So over here, I'm going to start by getting the x by itself. So we end up with -3/7. Remember, if it's a negative on the bottom, you can bring it to the top, same thing. Makes the whole fraction negative. Over here, I'm going to divide by a -1. And when I do that, remember, I have to flip my inequality symbol because I divided by a negative over the inequality. Now I'm going to subtract the 2 and divide by the -7. And I end up with something like that. So, let's see. I flipped my inequality, and then I had to flip it again. Yep. And over here, I see my mistake. I forgot to flip the inequality here. So, there we go. So always check that in the end. So now we have our two inequalities. So x can either be less than -3/7 or greater than 1. This is an OR. So to write it as a set, if it's less than, it can be from -infinity up to that value. Or it can be from 1 to positive infinity. So on our number line, I don't know all the fractions, so we're just going to write that. And then we got a 1 here somewhere. Just make sure they're in the right order. So we have our curved, or we have actually square brackets on this one because of the inequality. So I forgot on this one as well, we have to use the square brackets because of these types of inequality symbols when they have the line underneath them, okay? So when we go to do our number line, the same applies. And then you could also have used a closed circle here as well. And then the arrows go outward. All right. So we have the positive version and the negative version. So I will start by subtracting the 2. I divided by a negative, so I'm going to flip my inequality. Okay. Over here, let's try dividing. This is going to flip. And it's going to flip again. It's either greater than 7/5 or less than -3/5. Yeah, I guess it's an or. Okay. So these are two things that are going to be an or because they're going in opposite directions. And it's excluding the values in the middle. I'll check that one over because I'm not sure why it's not following the rules that it should be following. But we did it twice, so. And these are going to be curved. But I could tell, because of the situation. Okay, we flipped it. And over here as well. I don't know. We'll look back at that one. All right, so for this one, first step is to get the absolute value by itself. And then we have the two ways to do it. Flip this. Yeah. All right, so we have x is greater than -11, but less than 1. Less than or equal to 1. So this is going to be an and, because if we're talking about values that are greater than -11 but less than 1, that's talking about the values between those two. So you would write it like this, and it would be square brackets because of these. So step 1, get the absolute value by itself. And notice I flipped the inequality here. So my two versions. Subtract 7 on both sides for that one. So x is greater than or equal to -5 or less than -9, because those two things can't be true at the same time. That's how you know it's an or. And it's excluding the values between -9 and -5. And we're using, once again, I forgot my square brackets here. So even when you need to use square brackets, you're never going to use them around the infinities, okay? Just around the numbers themselves. And that's